We're so used to, this is very weird in Ubisoft, actually having more than one mic between us. We're used to just fighting for the mic in the panel. We've had a long day, and I think some of us have had a very long week here in Montreal, progressing the Vulkan standard. And one of the things that you heard across the day was, we want your feedback, we want your feedback, we want your feedback. And I was wondering, in the 2 years we've had of Vulkan, but especially in the past 12 months where people have really been using Vulkan in the real, are we taking that feedback on board? Can we think of examples, and what can we say about how we've taken that feedback from developers to change things in the API? Who wants to kick us off?
Sorry, that sounds
Hi with the laptop.
Yeah. I have a list of things. They're both important and some nonsensical, but probably also important. And I do apologize that there are some of these things are under discussion in Khronos, so I can't go into very specific details, but we would like to give you an idea of the things that the ISVs have provided feedback on, and also community people have provided feedback on that we're actively thinking about and arguing, borderline bloodbath. So the few things that have come into Vulkan as by way of ISV feedback and community feedback is obviously my presentation, descriptor indexing, and legalization in HLSL to make sure that people coming from DX, that their shaders work, and the thing that was popular for a while, that was a hot topic discussion, was the shader model 6 wave ops. That's in Vulkan 1.1. There were the ability to transition depth and stencil separately. There was some very, very vocal feedback on that, and that happened in 1.1 as well. There's this one, which I didn't know to be a problem, but apparently there's a lot of people who work on remote desktop, and that was a problem for a while, but as of Redstone 3, that seemed to be fixed. And so those are the major highlights of the things that because of community feedback and constant, I won't say heckling, but you guys nudging us about these are the things that are important that have been addressed over the last year. And some of the other things that have been raised recently, or at the same time that we're still working on, is execute and direct. We're aware that there's a lot of interest in this. This one's been implemented, but it's not. There's still some things in Vulkan we need to sort out. Is the semantics on the HLSL side. We have that working in the Spirit V. We just need to get that into the drivers. And I know this to be a favorite for many of you is the counting fences. This one it's important to us, and it's under active discussion. And it's one of the things that we have on our list as high priority to get right. There's also here, and some of these remaining ones are things that we need more feedback on, because we need to understand the use cases, because there are things that are possible in DX that aren't quite possible, or that may or not be possible in Vulkan. There's been a request to be able to reassociate a command buffer with a different command allocator. I know that's a hot topic on some discussion forums. And here's an issue that was raised recently that we're trying to sort out, is the texture arrays, and textures are two different types in Vulkan. We're quite aware that's an issue, and I know this is a Tiago favorite, is sparse resources, and that's something that's in the spec, and it just needs to be, there probably just needs to be more unilateral support across the platforms.
So is there anything that Hi has not covered?
I have one other thing, just one tiny thing, is that there's been a lot of people in the community that expressed the need for some type of residence control, and that's something in the most recent face-to-face we've started discussing. And again, these are the longer list is under NDA, so we can't go into specific details, but what we want you to know is that your feedback really shapes how Vulkan moves forward. and please provide us feedback at the most brutal level possible, because that's the only way we're going to learn. So don't sugarcoat anything to us. Tell us, like, this is what I want. This is how it's used, and we'll sort it out internally, figure out what the the use cases are from you.
Yeah, I mean, the important thing is when you say you need a feature, it's really important to describe what you're trying to do and how this is going to help you, because sometimes we may have other ideas for ways you could solve the problem, and it's just not, it's just not communicated very well how that could be used in Vulkan. But just knowing the use case and why you want to be able to do this is very helpful for us to know, okay, this is the use case that maybe we're missing. We didn't think about that case, and so that's a really important thing to come along with your feedback of these are things we need.
And I think going back to one of the points I was making in the introduction, which arose from discussions over a beer, is understanding the challenges that we have. As in, it is challenging to have an API that works across so many vendors, with each vendor having their own unique hardware, but there is massive benefit in doing so. But it does mean that at times we do you have your perfect way of making something work on a particular vendor. You want us to just implement that and expose that exactly like that, but that will be absolutely awful on another implementation. And that's what the working group tries to do, is actually understand what is the requirement. Is there a way we can expose this actually works for multiple people's hardware?
Yeah. The other thing, I mean, just to expand on some of the things that we've done based on feedback, is there's been a good number of Ext extensions that have been released over the past year that are not in core yet, and part of that is just because they're important use cases for possibly some parts of the market, but maybe not for everyone. Just bandwidth of the working group to be able to get everything done, and so there's a lot of things that are there because people have asked for them, and maybe they're supported across the desktop vendors, but maybe not the mobile vendors yet, or things like that. So
yeah, and there are things that have made it into 1.1 that were frankly somewhat surprising because of the pull from either ISVs or platform implementers. Protected memory, for example, came in because there was just it was a drop dead, can't do this without some sort of protected memory feature to be able to enable DRM kind of content in the Vulkan environment. So we get pulls, and sometimes we can turn them around relatively quickly, and some things they have to kind of stew around for quite a while to try to figure out what the right answer is.
Yeah, I mean, so other things in Vulkan 1.1 is like memory sharing. I mean, that was a huge, there's people who want to build compositors for their operating systems in Vulkan. You need the ability to be able to import memory between processes and that, and things like YUV support as well. It's really important on Android, for devices that have cameras to be able to get data into Vulkan.
So shall we throw the discussion open to the floor? Who wants to kick us off with a prickly question? Do we want to come back to one of the ones we had earlier? No one dares. Go on.
Okay, I'll bite. Okay, so this is maybe kind of a broad question, but I think a lot of the people here are from, places like Ubisoft, large developers that have large teams potentially. And I'm kind of here as a small independent developer, and I'm possibly my only engine programmer. So I'm looking at Vulkan, and I'm coming from OpenGL, which I think I saw some Vulkan doc that describes like OpenGL gives you a set of like heuristic defaults that sort of make sense, and Vulkan lets you decide what you want. And these are both great, these are kind of just both extremes. What it seems like from my perspective, like if general programmers are going to be able to actually do anything with Vulkan, it seems like something you need is, it gives you some kind of a sensible default, and then you tell it what you want different. Because if I look at what I want with Vulkan, if I want to use Vulkan, it's because I want to do something very specific, but it's maybe not my entire stack. Maybe I just want to do something weird in one case, but I can't use Vulkan for just one thing. So I'm curious if you see a path from where you are now to a point where someone can just sit down, draw a triangle without spending 2 weeks reading tutorials, and then once they've got the triangle, go, well, actually I want to do something a little bit unusual with how I've set up my pipeline. I think the idea was always open source is going to step in to fill the gap. I'm not sure I see that happening. I think most people seem to still be just working with basic Vulkan, even if they're standalone programmers.
Yeah. So a little bit more than a year ago, I was in your exact same position, asking pretty much the exact same question, and it took, to be quite honest, it took a little bit of prodding to get for people to recognize this. But it has come up as an issue in our 2 most recent face-to-face meetings, and the spec now actually has a lot of this I won't say a lot, but it actually has a good bit of this information in there. It gives you some recommendations on, here's what you would expect to do with the default, and here's what there may be great undefined behavior. It's not to say that we couldn't do better at that, and I think this topic has come up, and the hard part of this is that there is a divide between certain platforms, or to be forward, desktop and mobile, that makes this hard, but it's not impossible. But it's something that I mean, I don't know if you guys agree, but we could definitely use some effort behind.
Yeah, I mean, I think one of the things is I hope that there will be, sort of the whole community will develop tools, but I know that's just kind of wishful thinking. But it's also a hard problem because what's right for one developer might not be the right level for another developer. So it's really hard to figure out what the balance there is, and yeah.
Yeah, and I think it's there was a lot of hope, and it comes back to what the philosophy of Vulkan was and why we said we're going down this explicit path of Vulkan, which is very much we don't want to have drivers misinterpret what a game engine wants. We want to have that more explicit control of what the GPU is doing. And it's also something that, again, has come up in conversation, that sometimes a vendor exposes something in another API, but doesn't expose it in Vulkan. It's like on the same hardware. And why is that? It's because in Vulkan, they're being very bluntly honest with you. This is what we have. This is what the hardware capability is. But when it comes down to kind of how do we foster the community, it is a challenge, and we kind of had Jordan talk about what AMD have contributed on memory management. I'd like to see more of those. I think an interesting project that's been recently open sourced is the Forge from Confetti, available on GitHub, which is a kind of under-engine renderer that Confetti use for their projects and they keep maintaining. But it's a challenge because obviously each company has their own interest, and that's what we try and, via the ecosystem forum and other means,
so, quick question. Were you at GDC by any chance?
Yeah.
Did you come to the Vulkan session at GDC?
I didn't have the $3,000 ticket, if that's what you're asking.
Oh, no, it was open to Expo. But regardless,
darn.
So Dustin Land from id Software at GDC actually gave a really nice talk on his journey as a non-graphics programmer into becoming a graphics, or I guess working with Vulkan on his Doom ports, or Doom and Quake ports. And he has a blog series that actually goes through and shapes, it tells you like how his understanding shaped as he was making his way through this. And I think this blog post has morphed into kind of like a collection of resources of how to get started in Vulkan. And it's a good place. It's a good place to just take a look at and understand that people with the same kinds of struggles with Vulkan have made it through. Yeah, definitely. I'm sorry, I don't have the URL in my head, but if you just Google Dustin Land id Vulkan, it'll definitely show up.
Along those lines, it will also be like we discussed a bit about the assistant layer there, and how IHVs might contribute to that layer. Would it be possible to make that a bit more formal, where we know IHVs want to push us in a certain direction? We know the API exposes certain things, but a lot of it is hidden, and we will have to make decisions in terms of engine design of which path are we going to take that will be fairly performant on most IHVs. Would it be possible to have a bit more central place where IHV would say, okay, without revealing any super specific secrets from our hardware, you should at least try to do these things besides just the limits. Limits of the hardware are like, can mean a lot of things. So it would be nice to have a bit more formal guidance on that.
And Mark, feel free to jump in as well. But I mean, from myself and Samsung, given we know how much developers love targeting 2 chipsets on the same device each time, trying to get the guidance from each GPU vendor and transcode it into a single, this is what you should do to get good performance on both, and at times you want to do different things, is a challenging factor. But do you think that's something we could do better at? Rather, because at the moment, effectively, kind of what I feel we give developers is each GPU vendor gives their advice. So you just have to read X number of different documents, and then you have to merge them in your mind. Is there something we can do that, with the portability layer that would make it better? Can we compel?
There's probably some we can do, but there's probably also some things that aren't going to be easy to do with that. So
it's been strongest so far, from my observation, on the compiler sides, where there's a bunch of transforms that happen to the Sphere V that are vendor neutral, that are also typically a win in the Sphere V tool chain. When you get down to implementing the actual command streams that you have, it does feel often like in order to get that absolute best possible performance, you're going to have to do some slightly different paths. But I think what we're trying to struggle with in our kind of standards groups is to say what gets you 95% of the way there and leave the last couple of percent off. That's not the lowest common denominator, it's a pretty high denominator. And I think Vulkan gives you a good chance of getting there. We're still early on in this whole process with Vulkan and getting people experience using it and us experience seeing real use of it. So we were talking earlier today about the 1992 and OpenGL. So part of me keeps looking back and saying how far we came in the short amount of time from Vulkan to today. We have a much healthier ecosystem of tool sets out there that you can actually go off and grab, and like the Vulkan memory managers. So all of that's positive, and yet we still need to do a better job of trying to get everybody up to a pretty high level.
Yeah, I think part of it is just that as IHVs, we're also still coming to grasp with, we're pretty new to Vulkan as well because it's only been out there for 2 years, right? So we're still trying to figure out the best way for workloads to work on that as well. So it's kind of a learning experience for all of us.
Did you have a specific, or I guess a few specific cases of what would be helpful? Because there's things that are going to be easier to do as far as general or even specific guidance than other things.
I mean, the bunch of limits that you have, the number of bindings, things like that, where it feels like we're hitting them, and then sometimes the reply is, oh, but because we just put that number not because of a specific reason, but it seemed reasonable. And I mean, it takes time for that number to change. It would be nice to know what things are a bit arbitrary, and things that have some reasoning behind it that, again, I'm not saying reveal any specific details, but if we want to do like an assistant layer that's useful, that's going to have to be concrete information there. Mm-hmm. It can be just like really high level stuff. That's not going to be especially helpful, I would think.
So that would also, I assume that you would want that in some type of like warning should you land on a platform that you're either reaching or this limit is not the same as what you were expecting.
Yeah, if you're talking about the assistant layer, I assume that's the format that's gonna happen. But it's like, will I only be able to see that information if I run it on my environment, or could that information be available as Oh, as a formal thing that the IHVs contribute to and say...
As a document,
yeah,
guidance,
it's just like some other format that instead of hitting those issues...
As opposed to being buried somewhere in some many layers of code that you're never going to go find and look, right? Yeah.
I think it'd be a fun discussion trying to create that document.
It sounds like something that may be applicable for the ecosystem forum.
Yeah. And the assistant layer is the ecosystem forum is the place where there's been active discussion on it. Because I know that ARM have been working on something similar and LunaG contributing to it. So merging those ideas, but on a mobile side on Samsung, we have a game dev page where we do try and merge the two bits of guidance together from different our two main GPU vendors, and it is an interesting challenge. Trying to do that with 7 or 9 would be challenging, but I think it's something we should take back and see if we can encourage.
Thanks.
So creating pipelines is it's a heavy process, and so I try to use pipeline cache to optimize that process, and I couldn't find any kind of optimization in that case. Is it especially when it's the first time you load a pipeline? So I was wondering if the IHFVs like they don't want to store proprietary information in there or something, or why is it?
Well, the first time you create a pipeline, it's going to be, that's basically when we have to go through and compile all the shaders and all that information, right? So the preferred way is, so it's going to be like your first run. Ideally, you're going to use the pipeline cache. So once you've started compiling shaders, if you keep using the same pipeline cache as you build more, if there's similar shaders, you might get some, if you have the same shader attached to different pipelines, you might get some reuse there. But the biggest benefit comes from when you save that off at the end, after you've loaded a level or whatever. What you want to do is you want to persist that pipeline cache to disk, and then pass that in, and then load that up the next time you run, and then that'll have.
That's what I'm saying. It didn't seem to help when I tried it on NVIDIA. And so once it's the first time you load a pipeline from the pipeline cache from disk, there were no difference in times between the pipeline that was loaded from the cache and the pipeline that was created directly.
Yeah, it should work. So
that's our experience on the mobile space as well. The first time that you create the pipelines are very, very heavyweight, but then coming back and hitting the cache gave enormous wins, even with relatively small caches. For one thing that you might have been facing is the cache being too small for the number of pipeline variations that you were having, so you actually weren't storing some of your stuff in the cache. But we've seen very dramatic differences in performances.
The best performance gains I got was through pipeline hierarchies.
Okay.
That was helping a lot when the distributor states were changing. That was helping a lot, but the cache I couldn't find anything.
Okay.
So what is, out of curiosity, what does this affect for you? Is it startup time or is it hitching when you're running, or both?
Well, right now unfortunately we create pipelines as we need them. So during a frame we can create pipelines. But it was mainly when during load time so I try to lower the amount of time spent creating pipelines.
So what worked for you was pipeline derivatives, or?
Sorry, what?
Did you say pipeline derivatives work for you, or?
Yes, those worked, but the pipeline cache did not.
Yeah, so that's a good example of something that works, that gives you benefit on some hardware, not others. And a colleague of mine, Ine Kim, gave a talk on this at GDC with examples on 2 vendors where we do see very significant benefits with pipeline cache use. But it'd be interesting to follow up on this to make sure we understand why.
But is it possible that IHVs just don't want to store proprietary information in there on disk? That is like
no. I mean, we certainly make advantage of the pipeline cache.
Yeah. Okay.
I mean, so for NVIDIA, we also have there's also the driver has a disk cache, a shader cache as well. So it's possible if you didn't see any benefits because it was hitting that, but. If it was slow all the time, that would be unexpected, and I encourage you to send an email to Vulkan support@nvidia.com so we can help you figure that out. So,
thanks.
Thank you.
Hello.
Hey.
as you know, GPUs are able to decode video, and so is there a good way to access that video in Vulkan and put that on a geometry easily?
Is this a staged question? What can we say on this? Everyone is silent.
Sorry for the question.
I wasn't quite clear on what the question was.
Being able to access the video decode and coding on some GPUs.
That is the feature that is being investigated, I think we could say.
Yes. Be interested to know about your thoughts on using it and integration.
Specific use cases here.
Yes.
Specific use cases is always helpful. So.
Yes.
So, sorry, what kind of applications are you developing for this?
So, actually, we are a film studio, and you're watching our movies in a VR headset. Mm-hmm. And so we are mapping the video on a geometry around the viewer. So
okay.
That's our use case.
So, right. Yeah. So if you, let's say in a hypothetical world that you could get this feature, what format would you want it to decode to? Or from?
Ideally, we would like to receive the video as YCBC Air, but anyway, in the fragment shader, we can do whatever.
So Vulkan 1.1 does have support for YCBCR texture formats. So I'm not sure if that covers what your use case or not.
The actual decoding actually.
Oh, the actual decoding?
Yeah.
Okay. Yeah, that's not.
So what kind of source formats would you be coming from?
Oh. We have MP4 in H265 encoded videos, and we are using the GPU to decode them and retrieve as a texture the frame, and then we use it.
Yeah, so at the moment with Vulkan 1.1, as Daniel was saying, you've got the texture route once it's a texture, but the actual access of the encode decode parts is not currently in is not currently available, but there is discussion.
But it sounds like you said you already had a GPU decoding solution.
Oh, we are on Windows. We are using the Windows Media Foundation.
Yeah,
okay. On Android, we are using what's available on the platform. So usually the Android Media Player.
So if, again, in a hypothetical situation, if you could decode on, say, like the WMF stuff, but you're decoding to a DX12 or DX11 surface, would an interop extension work for you?
That's currently what we are doing, because we are rendering using OpenGL.
Right.
But since we want to have better performances and we want to have something which is better integrated at all the level of the decoding pipeline, I was wondering if you were working on that and what you were thinking about these kind of features.
We can either confirm or deny, but it would be a cool thing to have.
Yeah, let's continue this at the happy hour. But I think you as said, that was felt like a very staged question for some people. Next question, moving swiftly on. Don't let that scare you off. Are people holding up for beer?
So it was mentioned that DXC for HLSL is going to be the path moving forward in terms of how do you actually have control or at least some weight into talking to Microsoft in changing stuff in HLSL, or this going to be a one-way?
Do you want me to answer that, or you want to answer that? You want me to answer that, or you answer?
So we have a very good working relationship with Microsoft. We basically added Vulkan-specific types like subclass input. They have happily accepted that. So I don't think there is any reason they will reject something like that in the future. So it is, I think, it's going very well. It's going fun.
All right, so that's more about Vulkan customizations, but yeah, I don't know. Are they taking direction into HLSL, feature requests for HLSL
Yeah, so I mean, so to give you a bit of history, like we've added a ton of things into with using the C+ style attributes, and thus far there hasn't really been any objections. In fact, both Lei and Hassan have write access to the repo, and so they can merge things that are relevant to Sphere V. As far as extending, I assume you ask this because it's relative, or it's related to extending the language. You know, there's no spec to HLSL, and so they, at least that we know of. So it feels like sometimes.
So while sometimes we would like to be able to extend it, it's really hard to know how to do that. Yeah,
but the thing is that if there's something specific that you're looking for, then the dialogue that we have with Microsoft is very open. I won't go too much into detail on this, but there's been a lot of interest in having a Linux version of DXC, and obviously, you know, we've floated this by them, and they said there's not a technical reason why we would reject it. So there's possibilities depending on what it is. Now, you know, if you say like, hey, we're going to add like 8-bit support in there, they might, you know, have a problem with that initially. But our relationship with them is pretty open. There isn't like a formality wall of anything. So, you know, we just have, like, if we need to know something, we just send them an email and they reply back.
Yeah, my question was more, let's say there's something in Vulkan that you would like to see supported in another API, and since we're all working on DXC, if you have to support that feature for Vulkan, why wouldn't that feature be also supported for the end?
So I heard a rumor, I'm not sure if it's true, but there's a secret gang of ISVs that apparently if you like slip a note somewhere, they could influence this.
Okay, I'll go over beers with that.
Cool. Anidi?
I did have one more question. Okay. So during the memory talk, talking about, you've got just take 70% of the GPU and leave 33% for the driver. And that was very interesting to me for the use case of what if there's more than one program running on a system, which is, I mean, not an issue on mobile. Games usually quite other stuff, but if you're just running a normal program, are you looking at some point, maybe as part of the residency requirements, or the residency extensions, just doing something to support the case of there's more than one program running and they have to interoperate somehow nicely?
So I didn't catch. Did they actually say leave 33% for the driver, or was it for other applications? I mean, I think generally
Jordan's sitting right behind.
Yeah, Jordan's behind. So
it's a bit of both. You want to leave some room for other applications to run, and also just for the driver and implicit resources, like swap chains is probably the biggest implicit resource in Vulkan.
I think
it sort of depends on, like, if you're obviously if you're trying to be like a full screen application and you want to be, you know, when you're foreground, you know, that's kind of the type of situation where it's good to take, you know, up to 70%. If you're just a normal application that you don't expect to be full screen, you probably want to scale back. And, you know, Windows has some mechanisms for exposing that. Other platforms aren't quite as mature in that area, so we're still working on how best to figure that out. And yeah, it's, you know, you try and use 70% of your memory on something like Android, you might not last very long at all. So it's, unfortunately at this point we're kind of at the experimentation. You know, you have to experiment with what works well for your application. And yeah, I guess knowing the types of things that you want to be able to do and know is good input for us to know. I know, you know, one of the things we've heard is, like, you know, being able to query how much video memory there is total, or how much memory total and how much is available right now is a good thing to do. But that's hard for on some OSs. It's hard to know as well, and it's hard for the driver, because in many cases the driver is just another. You know, I know they mentioned about the, you know, with the angle discussions, like, well, the driver's just the angle is just user space, so it could be, well, actually for Vulkan, most of the Vulkan driver is actually user space, and there's very little that's kernel. So it's a very hard problem to solve and to solve well. So we are working on trying to come up with that. So
thanks.
Okay, any last question? I see, so I know the beer is here, so one last question to finish us off.
Hey, you're probably not going to answer that, but is there any plan to support more consoles on Vulkan?
I think you have to ask your console vendor.
So, I think, kind of going back to the beginning, Vulkan's an open API. Any platform is very welcome to adopt it, but it's obviously up to the platform and their commercial interests and how much developers pressure them or don't pressure them to adopt it. That makes a decision. But yeah.
If you're interested in seeing it, make sure your console owner, the platform owner for that console or whatever platform it is, gets lots of requests. That's the only way. Most of us don't really have direct influence on that either. So.
Yeah, our hope is that as Vulkan matures and more titles use it as the first port, the first renderer, it becomes more and more attractive for other platforms to adopt it. But I think obviously, if the current API they have fits their needs, that incentive is not there. So.
And the portability initiative, targeting the Mac right now, but there is interest potentially in bringing that same set of tools and layers over onto consoles if there's interest.
So Neil over there is Khronos president and chair of the Vulkan Portability TSG, and I think so understanding your experiences, if you've evaluated the portability tools, and especially as Mozilla is currently working on bringing them over to D3D, so having Vulkan run over D3D, understanding how useful that is, and the evaluation from you guys is very helpful to direct that. Okay. Right, so I think let's wrap it up at that point, and we're just going to have one slide to close us off, and then there's beer. So you guys just stay there for a second. So thank you again, especially thank you for all of you speakers, all of you for managing to get through the day without falling asleep. We now have beers outside and inside very soon for another hour of discussion. Reminder, all the videos and slides will be up on the website very soon. Please do fill out the survey, as in we really do value your input. We want to know, what did you think went well today? What could we do better? What areas do you think we need to address and have more tutorials and events on? And I've got Chantel looking at me.
Just to let you know that actually all the setup is outside for you guys. There's food, there's drinks, but nothing will be inside.
Thank you very much. And thank you again for Ubisoft for having us today and for all of you today. Thank you.